Different tools have different jobs. I imagine if you thought of a tool, you might think of something like this, the screwdriver. A wrench is a tool as well. But so is a scissors. But so is a spoon. All these different tools have different jobs. If you are going to hang a picture, you might be using a screwdriver. But there are two different kinds of screwdrivers that I have in my hand right now. Can you see the tips of these? One is called a slotted screwdriver, and the other one a Phillips. If your screw head had a line in it like this, you would use the slotted screwdriver. That would fit perfectly into that hole. And if you had a screw that had this on it, you would need to use this screwdriver. So even though you said, oh, I just need a screwdriver, you would need a special kind. If you were using a spoon, would you need a spoon like this? What about a spoon like this? Why would you ever have a spoon that had holes in it? These spoons have different jobs, and even though they all scoop, they are used slightly differently for the circumstance. Well, math is kind of like that too. Math has different tools, and we are learning about some of them now. If you have a certain reason for having the tool, you would know which one to select for which job that you needed to have done. Some of the tools of math are the properties. We have certain rules for these properties, or the certain way that math behaves. In multiplication, we have something called a commutative property. We have an associative property, identity, distributive, zero. These are all properties, and they all have certain rules for them and places where that you can use them. So when we're doing multiplication problems, we can use some of the ways that these tools work, which are different from each other, similar but different, similar but different. We can use some of the similar but different rules for different situations when we're multiplying, and that can really help us get the answer correct and quickly. Let's take a look at some of the examples using the different properties, and I'll explain them as we go along. Do you remember when we were doing these problems, 12 times 47, and I asked you if you wanted to keep it or flip it? I was really talking about the commutative property. And why would you want to keep it or flip it? There was an easier way to do it if you followed one of the other rules. When there's a 1 in the problem, anytime you multiply anything times 1, it's very easy. You just have to copy the other number. That's what's called identity. The identity property of multiplication says if you multiply 3 times 1, it's 3. And if you multiply 3,033 by 1, you get 3,033. So in this particular problem, we could commute the numbers, that means flip them around, and put the 47 first and times it times the 12. We're using the flip or the commutative property, and then we're going to take advantage of the identity property when we multiply by 1. The problem looks like this. 1, 2, the 2 is in the ones column. You're going to go ones column to ones column. 2 times 7 is 14. I'm going to put down the 4, and the 1 spills over. Now we're going to take 2 and multiply it by 4 tens. 2 times 4 is 8, plus 1 more is 9. I'm going to put the 9 in the tens column. We're done with the 2. We're going to X out the 2 spot, the ones column spot, before we go on to multiply by 1. The identity property of multiplication says anytime you multiply anything by 1, it's that number. So I can just copy down 47. Now I'm going to add the partial products. 4 drops into the ones column. 9 plus 7 is 16. So 16 has to be split. I can only use the 6 in the tens column, and I'm going to spill over the 1 to the hundreds column. 1 plus 4 is 5. We use the commutative property and the identity property when we did this problem, and it made it easier for us.